Swayam Prabha. Digital India. Educated India.
Good afternoon and welcome back. Let us continue with the topic food deterioration models and shelf life testing in the lecture number 19, part 3. So in the previous lecture, at the point when I stopped the lecture, so we were discussing about the Q10 model. So this is the second kinetic model. Let us have a quick recap what that we have discussed towards the end of the previous lecture. So this model is used to predict the changes in the reaction rate, especially for every 10-degree rise in temperature. So that is why it has got the name Q10 model. So the shelf life is predicted under varying temperatures or various at different temperatures. This is not an accurate model for complex degradation mechanisms, products with complex degradation mechanism. So let us move to the mathematical part of the Q10 model. So this is the formula Q10, that is R2 by R1 divided the whole power 10 divided by T2 minus T1. So using this formula we can find R2 as R1 into Q10 to the power of T2 minus T1 by 10, where R1 is the reaction rate at temperature T1, R2 is the reaction rate at temperature T2, L1 is the shelf life of the product at temperature T1 and L2 is the shelf life of the product at temperature T2. So this is the formula. So if you want to find out the reaction rate at temperature T2, we can use this formula. And if you want to find out the shelf life of the product at the temperature T2, we can use this. So based on this Q10 model, let us solve one numerical question. Estimate the time of spoilage for a product tested at 3 different temperatures, 20, 30 and 40 degrees centigrade. The corresponding reaction rates are 15, 24 and 38 respectively. So 3 temperatures are given, T1, T2, T3 and 3 reaction rates given, 15, 24 and 38 respectively. Assume the shelf life of product is 8 weeks at 20 degrees centigrade. So let us solve this problem. Problem number 4. This is based on Q10 model. So 3 temperatures are given, T1, T2 and T3. T1, T2, T3 are 20, 30 and 40. 20 degrees centigrade, 30 degrees centigrade and 40 degrees centigrade. The corresponding reaction rates are K1, K2, K3, K1, K2, K3, 15, 24 and 38. 15, 24 and 38. Shelf life of the product at temperature T1 is given, that is, so L1 is given as 32 weeks, which is about 8 months, So the temperature T1, 3 temperatures are given, 3 reaction rates are given and L1 is given. So we have to find out estimate the time of spoilage. We'll solve this problem step by step. So using R1 and R2, first I will be writing the mathematical expression based on Q10. Then using R2 and R3, a similar equation will be written. So Q10 is equal to, using R1 and R2, using reaction rate R1 and R2, Q10 is equal to R2 by R1, the whole power, R2 by R1, Q10 is equal to, Q10 equal to R2 by R1, the whole power. In the power, we have 10 divided by T2 minus T1. 10 divided by T2 minus T1. 10 divided by T2 minus T1. So this is in the power, exponential. So substitute the values, you will get R2 is R2 by R1. Sorry, the reaction rates we have, if we go look at the Q10 formula, so this is the Q10 formula. So here the reaction rate is expressed as R1, R2. So let me use the same notation. So these three will be R1, R2, R3. So this will be R1, 15, R2 is 24, and this is R3, which is equal to 38. So let us substitute the values. R2 by R1, that is 24 by 15. R1, R2, R3 are reaction rates at T1, T2, T3 respectively. And you can take as K1, K2, K3 also. So this is equal to the whole power 10 divided by T2 is 30, T1 is 20, 30 minus 20. So if you calculate, we will get Q10 is equal to 1.61. 1.61. So using R2 and R3, similarly, I will be writing the another equation. R3 by R2 equal to R3 by R2 to the power of 10 by, instead of T2 by T1, I will write T3 by minus T2. T3, instead of T2 minus T1, I will write T3 minus T2. This is using R2 and R3. Let me write this one. Using R2 reaction rate 2 and R3, I will write similar equation for Q10. Q10 is equal to R3 by R2, the whole power 10 divided by T3 minus T2. So substituting the values, R3 is 38, R2 is 24, the whole power 10 divided by temperature T3 is 40, T2 is 30, so 40 minus 30. So simplifying, we will get, using R2 and R3, the Q10 value will be 1.58. 1.58. 1.58. If we compare these two values, from these two calculation, that is, we have calculated Q10 based on R1 and R2 and Q10 based on R2 and R3. So here if you see the actual, in the first one, when we are using R1 and R2, the Q10 value is 1.61. Q10 value is, actual Q10 value is 1.61, which is not doubled. So in case if it is not given, then we have to take Q10 as the double value, twice the value, for every 10 degree rise in temperature. That is the concept of this Q10 model. But now, since the temperatures are given, when we calculate, we found Q10 is not it is not equal to 2. It is not equal to 2. It is not equal to the theoretical value of 2. Now, I am going to write the mathematical expression connecting L1, L2, T1 and T2. So So using T1 and T2, using the temperatures T1 and T2, we get L2 equal to L1 into Q10, L2 equal to L1 into Q10 to the power of T1 minus T2 by 10. So T1 minus T2 divided by 10. If you go back to the Q10 model theory, so this is the formula I have written. This is nothing but L2 by L1 equal to Q10 to the power of T1 minus T2 by 10. So this is the formula which I have used there. So I will be using this formula. So L1 is given as 32 weeks. This is given. Q10 we have calculated. T1 and T2 are given. So substituting, this is 32 weeks. Q10 is the one which I have calculated using R1 and R2, that is 1.61. This is 1.58. So this I will take the maximum one, 1.61. T1 is 20 minus 30. T1 minus T2 by 10. 20 minus 30 by 10. Correct. 20 minus 30 divided by 10. So solving this, we will get L2 as 19.9 weeks. That is close to 20 weeks, which is about 5 months. 19.9 weeks, which is approximately 20 weeks or 5 months. So when we are using the actual value of Q10, which is the calculated value 1.61, the predicted shelf life is 19.9 weeks, which is about 5 months. So that is what we have to calculate, estimate the time of spoilage for a product. Let us continue with the third type of the food deterioration model, that is called triple T model, time temperature tolerance model. So this is used to predict the shelf life of the product like the other models, particularly frozen food product. By considering the impact of time, as the name indicates, it is temperature time tolerance. Graph is plotted between the temperature and the time, and accordingly the analysis has been done. So to study the impact of the temperature on the quality, when we say quality, it is the texture, taste, the color, the shape of the food product, etc. The model considers how temperature affects the chemical reaction and microbial growth. In one of the earlier lecture, told about one of the factor which affects the shelf life is the temperature at which the food product is stored. Freezing prevents the growth of microorganisms, but even under freezing condition or even the frozen food, there are chances sometimes in some frozen food products the microbial growth will be there. When we go for low temperature, then it can reduce the growth of microorganism. It cannot eliminate it. So that is the point which I am highlighting here. The model considers how temperature affects the chemical reaction and the microbial growth, which ultimately determines the stability of the product. Foods that spend too much time in the danger zone, that is 4 to 60 degrees centigrade, becomes a breeding ground for bacteria. The foods which are in this temperature range, the environment is conducive for the bacteria to grow. This method can be used to forecast the shelf life of non-frozen foods also, though it is mainly used for determining the shelf life of the frozen foods. However, it could be used for non-frozen food products such as mushroom and potatoes. The degree to which the products can tolerate the effects of time and temperature is termed as time temperature tolerance. The extent to which the product can tolerate, can withstand the impact of the temperature with respect to time. That is why it is called as time temperature tolerance model. So this is the time temperature, the tolerance model. If you see, this is the y-axis is the growth rate of bacteria and the x-axis is the temperature. So here if you see, there are different classification of microorganisms based on the temperature range. For example, if you take this psychrophile, so it is the temperature range is about -5 to 20, -5 to 20. So this is about -5 to 20 degrees centigrade. Mesophile, this is another kind of bacteria. This psychrophile type of bacteria, it normally grows when the temperature is very, very less, like very cold environment. Mesophile, if you see the temperature range, it is from 15 to 45. 15 to 45 degree centigrade. Thermophile, it's about from 45 to, thermophile, it starts from 45 to 80 degree centigrade. And hyperthermophile, it is from 65 to 105 degrees centigrade. If you compare the thermophile and the hyperthermophile with psychrophile and mesophile, these bacteria grow when the temperature is quite hot, like 45 to 80, and here in this case it is 65 to very hot. Whereas psychrophile kind of microorganisms, they grow in a colder environment when the environment is cold, and mesophile is about in the moderate temperature, neither too cold nor too hot. So experiments are carried out to identify the time and the temperature combination with respect to change in time. The temperatures are monitored, and accordingly the graphs can be plotted. So in order to find out the degradation of the food product, using the data, that is T time temperature tolerance chart is created. That is, a graph is plotted, as I mentioned little ago, which represents the shelf life at different temperature. TTT chart is used to predict how long the food product can be stored safely. Ultimately, if you take whether it is a kinetic model or a Q10 model or a TTT model, time temperature tolerance model, the primary purpose is to minimize the loss, minimize the wastage or the spoilage of the food items, and to maintain the quality, and also for safe storage, Let us move to the next topic, testing procedure of shelf life of food items. So it's a step-by-step procedure. It is, most of the points are self-explanatory. I'll just quickly run through it. First one is identify the specific food product and its packaging. Because when it comes to packaging, there are different methods like controlled atmosphere packaging, CAP, modified atmosphere packaging, etc. Specify the desired storage condition such as temperature. Whenever you come across the term storage condition, it refers to primarily to two parameters. One is temperature, another one is relative humidity. So such as temperature and humidity for the chosen food product. Next, we have to determine how the food product will deteriorate during the shelf life. That is due to the growth of microorganisms, chemical changes, or physical damage. Select appropriate testing method to evaluate the food product's quality and safety. So to select appropriate, it's a very, very important one. Prepare samples of the food product to be stored under the defined conditions. It is suggested to have as many samples as possible in order to have accurate results. A larger the size, number of samples, better is the accuracy of the result. Next one is store the samples under controlled environment and conduct the test periodically to evaluate the quality. Collect and analyze the data from the test for trends in quality changes. So, for various samples which have been tested, data to be converted into a form of a graph or into a form of a graph for analysis purposes. Estimate the food product's shelf life under normal storage condition based on the analysis. Compile the data, the findings and the recommendation in the form of a comprehensive shelf life study report. So, right from the sample preparation stage till the report compilation stage, there are a lot of steps involved, like as I mentioned, right from the sample preparation stage till the report comprehensive report preparation stage, there are a lot of standards, guidelines to be followed. Store a separate batch of food product for a longer period to confirm the predicted shelf life. Monitor the product in the market to track its shelf life and identify any issues. So once the testing procedure is completed at the laboratory, wherever it is conducted, a comparison have to be made with the real time when the product is sold in the market. How does the feedback have to be taken. So if there are any corrections or any changes to be done, or if there is any issues are there. So that is monitoring the product in the market to track its shelf life and identify any issues. So with this, let me conclude this lecture. Thank you.